Okay, whether screen is visible? Screen is visible. So good morning. So today we will continue with the procedure of design of slab base. I think we have covered uh, 5 to 6 steps. So design of slab base. So I think we have covered 6 steps. So we will continue with the step number 7. So step 1 was the uh, calculate bearing strength. Then step 2 was we have seen, that is calculate bearing area of base plate. Then in step 3 we have calculated the size of base plate. Then in step number 4 we have calculate intensity of pressure. Then in step 5 we have calculated the thickness of base plate. Thickness of base plate. And in step number 5 or 6 we have decided to provide 2 or 4 anchor bolts. 2 or 4 anchor bolts with cleat angle. So these 6 steps we have seen as a part of procedure of design of slab base. So now we will continue with the step number 7, that is calculate the size of concrete pedestal. Calculate the size of concrete pedestal. So similar to size of slab base, we have to calculate the size of concrete pedestal. So for that we have to calculate first area of concrete pedestal. We have to calculate area of concrete pedestal is equal to AF, concrete pedestal, or we are saying foundation. So AF is nothing but area of foundation or concrete pedestal. So AF, how to calculate AF? So AF is P into gamma m naught divided by SBC. P into gamma m naught divided by SBC. So now where AF is equal to area of foundation block, then SBC. What is SBC? SBC is the safe bearing capacity. SBC is the safe bearing capacity. Then P is the factored axial load. P is the factored axial load. So here we have to decide the size of concrete pedestal. It means length and width of concrete pedestal. So for that we have to calculate first area of concrete pedestal. So how to calculate area of concrete pedestal? F is equal to P into gamma m naught divided by SBC. So here AF is the area of foundation, SBC is the safe bearing capacity which will be given in the problem statement, safe bearing capacity of the soil where you are constructing your foundation or building, and P is the factored axial load. So by using this given data, you have to calculate the area of foundations required. So after the similar to size of base plate, we have to calculate the now length of foundation and width of foundation. So how to calculate length of foundation? So length of foundation is equal to LF is equal to LF is the length of foundation. So we got the area of foundation. So now we have to calculate the length of foundation. So length of foundation formula is length, length of plate minus width of plate divided by 2 plus under root of under root of length of plate minus width of plate divided by 2 square plus area of foundation. So in this way we can calculate the length of foundation. So this formula we have to use. Similar formula we have used for the base plate, length of base plate. Same formula we have used. So similar formula we have to use for the length of foundation, calculation of length of foundation. So now from the length of foundation, so here generally we have for the if we use the rectangular foundation, then uh, your area of foundation is the length of foundation into width of foundation here, but area of foundation is equal to what? Length of foundation into width of foundation. So here width of foundation is equal to what? Area of foundation divided by length of foundations. So in this way we can calculate BF is nothing but here width of foundation. So we can calculate with the help of area and length, we can calculate the width of foundation. So we got the length and width of foundation. Uh, Here we calculate the length and width of foundation, but foundation having one more dimension, that is depth of foundation. So here uh, depth of foundation depth of foundation uh, is depth of foundation is, assume we have to write here, assume 45-degree distribution. It means what? Depth of foundation is assume 45 distribution. It means what? So this is the your foundation, this is the your base plate. So this distribution at 45 degree, this distribution at 45 degree. So that we have to, in this way we have to calculate the depth. So this is the depth of foundation. So depth of foundation is like this. So from this point, if 45-degree angle we uh, take the 45-degree angle, so this will be the depth. So how to calculate this depth? So depth of foundation df is equal to generally length of foundation minus length of plate. See, length of foundation minus length of plate divided by 2. So how to calculate depth? This is the length of foundation, this is the length of plate. See, this is the length of foundation and this is the length of plate. So if we take the difference of length of foundation minus length of plate divided by 2, then it means this distance and this distance near about equal. This distance and this distance near about equal. So by using, if we see this formula, so this formula, it means here by calculation we are getting this distance, this. So generally we have to provide this and this distance equal. Are you getting? So in this way depth of foundation you can calculate. So here step number 7 is over. Are you getting how to calculate depth of foundation? Please draw the sketch. So sketch is very important. The distribution of load uh, up up to the depth in the 45 degree distribution is there, distribution of load. So for that, this 45 degree is here they have make as per the procedure of the IS 800 2007. Okay, and now last step, step number 8. Step number 8 is step number 8 is design of welded joint. Step number 8 is design of welded joint for column and base plate. So generally for column and base plate we are designing the welded joint. It means what? This is the your base plate. This is the your I section column. So now this column and I section you have to weld. So you have to weld means this is the your welded area. In this area you have to weld. So you have to place base plate, and on the base plate you have to fix the I section, this, and this column is vertical. We have drawn this in the plan. The sketch in is in the plan. So the height of column is the above this plan. So we have to, if we place this I section on this base plate, we have to weld around this column. So then the joint of this base plate and column will be there. Okay, so now we have to find this length. How to find this length of weld? So that length we have to find out now. So here while designing the welded joint, so first we have to calculate. See, first we have to calculate total available length, total available length for welding, total available length for welding. Now this is the depth of your I section, this is the width of your flange, this is the your thickness of wave, this is your thickness of flange. Okay, so now we have to calculate available length. So this much whatever I have here dotted, this is the your available length for welding. So available length for welding, for first we will calculate for I section. As a column we can use channel section also. So here first we will calculate available length for I section. So available length is equal to available length for welding is equal to, see, I will write first formula, then I will tell you how this formula comes. 2 into bf plus bf minus tw plus d minus 2 into tf. See, this width of flange, see here, bf plus bf, it means this side bf and this side bf. These two flanges are there for I section. This is one flange, this is second flange. Now here written, I have written bf plus bf. It means what? This side plus this side. Minus tw, it means this thickness we have minus here. Are you getting? This thickness. Here we have add two flange. It means what? This side plus internal side. We can weld by two side. This is the top side and this is the bottom side of this flange. But in the bottom side we have to deduct the wave, thickness of wave. Are you getting? Now how did, why deduct, we have deduct the thickness of wave? Okay, plus depth of section, this is the depth, whole depth of section is there. Then minus plus d minus 2 into thickness of flange, 2 into thickness of flange. It means this side we have to weld and this side for one flange, left side and right side. 2 into tf, it means this is one side, this is second side. So for these two sides we have to weld to flange, and outside 2 is there. So every, so here 2 is for what? Because this bf plus bf, it means one flange is there. So this side another flange is there, so for that 2. Then tw minus tw for this side and this side, because both flange are there. So for both flange we have to deduct tw, so here again multiply by 2. Then plus d, so the d is for this side, again opposite side also depth is there, we can weld for opposite side also this side. So here 2 is there, again multiply by 2, minus 2 into tf, 2 into tf for one flange. Similarly one more flange is there, for that again multiply by 2. So this is the your total available length for the welding. Are you getting? This is the available length for welding. So this is for I section. So similarly for channel section. Similarly for channel section. So if I draw the sketch for channel, again you can see here. So this is the base plate. This is the your channel. So here you can weld like this. If your channel section you have used as a column, then you have to weld in this area. Are you getting? So now this is the depth of your channel. This is the your flange. Then this is the thickness of flange. This is the your thickness of wave. So now for channel, how to calculate available length? So here available length is equal to, again here I will write first formula, then I will explain. BF plus again BF minus TW plus D minus 2 into TF. So I think same formula is there for the flange also. Or only one TF is required here. Thickness of flange. This side depth is coming. So here only one T will be there. Instead of this, okay, only one TF we have to minus. Okay, are you getting? So this side, this and this side only we have to here minus thickness of flange. So one thickness of flange here minus. So here 2 is there for second flange. Again same BF plus BF. This is the width of flange. Again this is the second width of flange. We have deduct thickness of wave this plus depth of flange. Is this required 2 or 1 only? This thickness of flange? Because internal D is less. Outside depth is more, but internal depth is less because we have to deduct this thickness of flange from both sides. So here we have deducted 2 times of flange. 1. Is this correct? Anyone can reply? As per whatever I have hatching here, this area I have calculated here. Area means length we have calculated here. So hatching length here I have written. Is this correct? So if you start from this point, so we have to measure the perimeter. So whatever perimeter I have measured here, is this correct? This is the perimeter. It means available length for welding. Is this correct? Or anyone can reply if it is wrong. Or this will be only 1 TF because 2 is here. So here one thickness of flange we have to minus, here thickness of flange we have to minus. So if we minus 1, then here 2 will be there. So I think here only 1 TF will be there. Please see, this is only 1 TF. Okay, this is the your formula for I section and channel section for calculate the available length. So this is the correct formula. Okay, is this over? Now, second, we have to calculate strength of weld. Strength of So strength of weld is equal to FUW divided by under root of 3 gamma M1 into TE into LW. So this is the your strength of weld. Now for that you have to here assume size of weld, assume size of weld. S is equal to, you have to assume, then T is equal to 0.7 into S, effective throat thickness. This we have calculated in the earlier unit number 2, 3, 4, strength of weld. So T is the 0.7 to S. So for that you have to assume S first. Then you can calculate the effective throat thickness. Okay. So now number 3 we have to calculate the here calculate the effective length of weld. Effective length of weld. It means earlier we have calculated the available length of weld. Now we have to calculate effective length of weld. So how to calculate effective length of weld? So by equating strength of weld and factored load. By equating strength of weld and factored load, we have to calculate the effective length of weld. So strength factored load is P into strength of weld is here FUW divided by under root of 3 gamma M1 into TE into this LW is the effective length here. This LW is nothing but here effective length weld. Means येणारा जितका लोड आहे त्या लोडसाठी आपल्याला किती लेंथ प्रोव्हाइड करावे लागेल. This length we have calculated, this available length, but actual how much length we have to provide, that we have to calculate from the whatever load coming on the your base plate or column. So if we equate now this factored load and strength of weld, then you can calculate here now effective length of the weld. And now we have calculated here effective length of weld, means that much we can provide, but is this available, that we have to show here. So number 4 we have to calculate here, calculate available effective length, calculate available effective length. So here after deducting end returns means what? These are the ends. These are the end returns or internal end returns. So these are the end returns. So we have to deduct this end returns. या ठिकाणी वेल्डिंग नाही केलं तरी चालेल. So we have to deduct this end returns. So by deducting the end returns, we have to calculate available effective length. And after deducting the end returns of the weld at the rate of twice the size twice the size of weld, twice the size of weld at each end. So this sentence is very important for MCQ. Please everyone note this. After deducting the end returns of the weld,